Assalamu alaikum guys. So today we are going to do displacement reaction. So what is a displacement reaction? The definition of displacement reaction. The definition of a displacement reaction is when a more reactive metal displaces less reactive metal from its compound. Okay, when a more reactive metal displaces a less reactive metal from its compound. Okay, so this is the definition of a displacement reaction. What are some examples of displacement reaction? Let's start with the first reaction of a displacement reaction. Let's start it. So today, let's copper sulfate, when it reacts with zinc, what happens is that zinc replaces copper, because in the reactivity series, if you have seen that zinc is more reactive than copper, hence zinc replaces copper, and copper is extracted from this equation. Okay, now let's do the another example of displacement reaction. Let's take iron when it reacts with copper sulfate. Okay, let's take iron when it reacts with copper sulfate. Let's see. So when iron reacts with copper sulfate, as we know that copper in this copper sulfate is less reactive than iron, hence it will displace its position with iron. Okay, so basically, displacement reaction means that when a more reactive metal displaces a less reactive metal from its compound. So in this, what we will get is FeSO4 plus C. Okay, in this reaction, we will get this product. But if we react copper with FeSO4, okay, what will happen? That copper, that there no reaction will be done. Okay, why? Because iron is already more reactive than copper. That's why no reaction will be done. That's the basic things. Okay, so these are the things which happens in the displacement reaction. Okay, so as in the first, let's write the observation in the first, and the in this first thing, that what happens when copper reacts with copper sulfate reacts with zinc. Okay, okay, so this is a picture of reactivity series. Okay, this is the picture of reactivity series. Even though it's not according to our syllabus, let me add things in it, because in our syllabus, it's the first thing is potassium. Okay, that's right. Potassium, sodium. Then the third thing is calcium. Then magnesium, aluminium, zinc, iron. Here it comes lead, and lead is not written. After iron, lead comes. Okay, Lead, lead. And yes, I think this lithium doesn't come in our syllabus. Okay, so so in between it lead comes, iron, lead, uh, copper, silver, and gold. Yes, so only lead is missing from here, and lithium is added over here. And over here, even though it's not a metal, but in our syllabus in the reactivity series, here comes carbon. As in the previous part, we have learned that carbon is used for extracting zinc, iron, and copper. Okay, we have learned that. No, zinc, iron, and lead, not copper. Zinc, iron, and lead. While over here, after lead, eh, here comes hydrogen. Hydrogen is used to extract copper, silver, and gold, and so on. Okay, copper, silver, gold, platinum, etc. Because they are more less reactive and so on. Okay, this is what a reactivity series is. Okay, so we are talking about the observation of this first chemical reaction. So what do we observe from this reaction? That before the reaction, this liquid was blue. Okay, why was it blue? Yes, yes, why was it blue? It is blue because of sulfate. Okay, so what do you observe? That first it was blue, and then after the reaction it turns white, and we can also observe it turns white. We can also observe that pink solid is deposited. What is that pink solid? The pink solid is copper. Okay, copper color is pink. Okay, so in this pink solid is deposited. Okay, in the second reaction, what happens is that solution turns from blue to green. Okay, why? Because copper sulfate is blue, has the color of blue, and iron has green color. When it mixes, first it's blue, that turns to green. Okay, the solution. And in this, what we can see is that blue solid is that green solid is deposited. Okay, sorry, pink solid is deposited because in this we take out copper, right? Yeah, copper. So again, pink solid is deposited. Okay, okay. And, yeah. And in the third reaction, there is no reaction. Okay, so we don't see anything which is reacting. So now we will come to the reactivity series. Okay, so let's write the properties of a reactivity series. So in the first property of reactivity series is that a more reactive metal displaces a less reactive metal. Okay, you know it in that in the reactivity series, more reactive metal displaces a less reactive metal. Okay, and in reactivity series, greater the reactivity of metal, more stable will it be the compound. Okay, so from it we understand that when the greater the reactivity of metal, stable will it be compound because when it because when reactive metal when a reactive metal loses its electron, it becomes more stable because the last electron is just like it's just like working like some some weight is on that electron that it had to carry it for. When it loses it, it becomes stable because it doesn't need any more electrons to be filled in the cell. So and when it becomes when the so the reactivity of metal depends on the number of electrons in the last shell, and when it becomes a compound, what happens is that
Shafisal.
that one reactivity that so it becomes stable because its electrons get filled. Okay,
Okay.
okay. So now the metals are above carbon in the reactivity series can be extracted through electrolysis. So the most reactive metals metals can be extracted through electrolysis. Okay, so okay, we cannot extract it by carbon or neither by hydrogen. Okay, we have to extract it by electrolysis. The metals below carbon can be extracted by heating their ores with carbon. Okay, for example, that hematite in hematite,
Shafisal,
carbon.
excuse me.
Yes, yes,
Your
yes.
ore.
And what is a ore? Ore is the mixture in which the iron is also present, and with it the impurities are also present. Okay,
In every metals.
yeah, and most of the metals are extracted by its ore, except gold,
Okay.
because gold we get it in the pure form. Okay,
Okay.
like
Okay.
and
So
iron.
gold is not ore.
No, gold does not have an ore naturally, but we make it so to make it a little hardened. Okay, and to give it a little more glow, and like because If we do not make it an alloy, then it will break easily, okay? Because it's too soft to be wear as a
Okay.
jewelry. Okay. So the metals below carbon
Okay.
can be extracted by heating their ores with carbon. You get it? You get this point?
Yes. 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 Yes.
Below carbon can be extracted by heating the ores
With carbon.
with carbon. Okay. Okay. So you get it? You got it now that
Yes.
why does we reacted with carbon? Because carbon is cheap and available. Okay,
Yes.
it is cheap and available. It is
Okay.
availability and cheap.
Okay. Okay.
Okay, that's good. Let to understand it. Okay. 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 So now, the metals below hydrogen can be extracted by beating their ores with hydrogen. Okay, the metals below. That's common sense that the metals below hydrogen we extracted by hydrogen. Okay. Okay, so metals below hydrogen can be extracted by heating. Okay, that's simple. So now we have done this, and now let's do what? Yeah. So now let me give you an example of that. How is it done by hydrogen? Okay. So the example is CuO plus H2. So when this does the reaction, what happens is water means H2O is created and copper is removed. Okay, from this reaction. So we are done this with the properties of reactivity series. Now let's go on the uses of the metals. Okay, uses of metals. Uses of metals. That's a lot of others. Okay, so let's do the uses of metals. So the first metal is aluminium. Okay, so the first metal is aluminium. Wait, let me change the pen. Okay, so the first metal is aluminium. So what is the use of aluminium? Can you any can anyone suggest me the use of aluminium? Yes, Josema or Ayan?
एरोप्लेन के पार्ट्स बनाने में क्योंकि वो
Yes,
लेस
yes,
डेंसियर होता है
yes. You are right. You are right. Making an aeroplane parts. Okay.
और केन्स वगैरह
Yeah, yeah.
ड्रिंकिंग कैंस
Aeroplane parts. Why? Because it's less dense
यस
and in cans
और
because it's
केबल बनाने
very
में इस्तेमाल
because
होता
it's untoxic. Okay, because it's
है
non-toxic.
यस नॉन
That's
टॉक्सिक
why that's why
वी कैन
it's
मेक
used in making cans. Okay,
कैंस
and
and
and what else?
making
And in
cable
making
also cable also because of good conductor.
yes, yes, yes. You are right. In making cable because of good conductor.
Yes,
Yes,
good
and you are
conductor.
also right. You have written the answer in the chat box. Uh, good conductor. Okay, so now we are done with the use of with the aluminium. Okay, so now let's go on with the metal copper. Okay, copper, copper. So what's the use of copper? In
It's
mostly,
usually used in copper wires,
yes,
making wires
yeah,
because of good conductor, nothing else.
yeah, yeah, yes, you are right. It's used in making wires because it's good conductor.
Yes.
You have done the homework, I think.
No, I studied before this
Yeah, yeah,
online class.
yeah. I meant it. Okay, so now let's go on zinc. Okay, let's go on.
Used for galvanizing,
Yeah, you yes, it's used for galvanizing.
galvanizing
Yes,
on the surface of
good.
iron because it is more reactive than iron.
Yes, it's used for galvanizing because it's more reactive than iron. Okay.
Shavesel,
Yes,
if I'm correct, you can observe me please. That galvanizing is what is the galvanizing process?
it is. Okay, so metals below hydrogen can be extracted by heating. Okay, that's simple. So now we have done this, and now let's do what? Yeah. So now let me give you an example of that. How is it done by hydrogen? Okay. So the example is CuO plus H2. So when this does the reaction, what happens is water means H2O is created and copper is removed. Okay, from this reaction. So we are done this with the properties of reactivity series. Now let's go on the uses of the metals. Okay, uses of metals. Uses of metals. That's a lot of others. Okay, so let's do the uses of metals. So the first one. So galvanizing is a process. Galvanizing is a process in which we melt the the metal over another metal for protect to protect it from rusting. Okay, so it is like a protective layer. Okay, layer on a metal. Okay, and that's the basic definition of it. So in zinc we use galvanizer. Okay, and why do we do it? And it's mostly used on iron to protect iron. Okay, why do we use it on iron? Because its zinc is more reactive than iron. Okay, more reactive than iron. Okay, so galvanizing is done. So let me give you a question. Why aluminium is unreactive towards
Sharp
water or
result.
steam? Yes. Why aluminium
Sharp.
is so aluminium so why aluminium metal does not react towards water or steam? It does not react with water or steam. Why? Josema, answer, please. Josema,
Yes, yes.
why the or give me the answer for this question.
I will answer you right now. Aluminium react with oxygen in
Yes.
air to
Yes.
form protective oxide layer on its surface, which make it unreactive.
Yeah, yes, you are damn right. To form protective layer because when aluminum starts to react with oxygen or water, the the first layer which does the reaction, it forms a protective layer. Okay, to form a protective layer on its surface. Okay,
Okay, okay.
and this layer, what does it do? It make is like it make is it as a barrier. It works as a barrier. Okay, barrier which make it less reactive. Okay, and this is an important question which is thoroughly asked in the past papers. Okay, yeah. So that's it for today, guys. So thank you for the lecture. I hope you guys have understood much. So now in the next class, I hope you know that we will start with a lot. So thank you, guys. I hope stay tuned.
Sharp result.
Allah Hafiz.